All right, so we are on Unit 2B. Unit 2B is about modeling, composition, and inverses, okay? That's what it entitles. So there's basically 3 overreaching concepts, and we're going to dive into each one of those. This is about a 10-day unit, roughly, give or take. That includes testing time. So from learning to test, it should be about 10 school days, okay? We're on 2B.1, parts A and B, competing function model validation. So, in part A, what we're going to start off with is we're going to talk about constructing linear, quadratic, and exponential models based on data set, which we have been doing since Algebra 2, right? We want to focus on what model best fits, what's the appropriate, and then analyzing that data, okay? So you have your reference sheet on how to do it, but hopefully we can try to use some of our memories and how we got to this point without us going through it. As you look right here, these are a regression model, but this was done in an Inspire, because that's what the notes included was TI Inspire visuals. I know we don't use TI Inspires, but their visual was with the TI Inspire. We're going to go through it with our A4s, and we're going to create the same table. Is that cool? Are we ready? All right, so if you have your calculator out, we're going to go ahead and create our data. It says Darren injured his hamstring in a football game. His sports trainer sent him to physical therapy to build up his leg strength by using a regulated weight machine. The table and graph show the number of repetitions he has been able to do on each day he was in PT. The best fitting linear function was y equals 2 and 500 x plus 4 95,000. 4 and 9,500, sorry. So y hat is telling us that this is a regression model. When you see y hat, that means regression model. That's the little party cone. And so we know that this isn't the actual model, it's the one that best fits it. Does that make sense? Okay, we can use the line to find the residuals. So we're going to work on finding the residuals. If you remember from Algebra 2, when we're looking for our residuals, what does that mean we're doing? Anyone? Yes. So how actual minus your predicted, right? So we're looking at how our actual values minus what it says using your regression model is, okay? That's the more explained. A residual is the difference between the observed y value and the predicted y value, but it's our actual minus our predicted. Do you remember that? And so when we look here, I'm sorry. Oh my gosh. That's what we're going to analyze and talk about where it's at. If you remember in Algebra 2, we talked about that's our least squares, right? When we want to try to make it the least area as we can, that's how we know it's the best fit. The one that gives us the least square amount. Okay, so I'm going to go to my calculator. I do not, it's just the R, yeah. We square it so that we don't have to worry about the negative, and that's why it's called the least squared. Yep. But right now we're just finding the R. So in our calculator, I'm going to reset Sylvie here. Second plus 712. Hopefully we're all good there. I'm going to go to stat, edit. I'm going to input the values. So my X's are 1, 3, 5, 7, and 9. My Y's are going to go in my L2, and we have 7, 10, 18, 17, 24. Do you all remember doing this? Feeling okay with it? All right. And again, if you need reference, you have your step-by-step residual handout. After we do that, we're now going to go to stat, and we're going to calculate. And we're looking for our linear regression model. And if I didn't know it was linear regression, I would go to y equals and turn on the plot. What this does is I want to be able to see the graph. So after I turn it on, you can't just go to graph. Remember, we have to go to zoom and then go to stat to see our points. So now when I look at this, do we see why I'm predicting that it is a linear model? Yes? It's going to be the same value. Yeah. I'm just showing it from the 84 perspective. Okay, so again, you go to y equals, make sure you turn on your plot, and then you have to go to zoom stat, which is zoom 9, and then it should, okay, and then it should appear like so. All right, so now this is what it looks like on the 84 compared to what it looks like on the Inspire. Next, you're gonna find your best fitting linear function, your y hat. To find our y hat, that's our stat, calc, and we're gonna go to linear regression ax plus b. So I press 4. In order for it to graph it for us, we have to store it. This is the most obscene amount of steps you have to press for it to happen. I apologize. I did not create the algorithm for the calculator. All right. Exactly. We got to go to vars, go to yvars, go to function, and then we go to 1. What this is saying is, hey, I want you to find this model for me. Not only do I want you to find it for me, I then want you to save it in the calculator and graph it for me. Okay, if you skip that step, it will not automatically graph it. So I'm going to hit enter. And Sylvie's just like, bam, here we go. Here's your line of best fit. So now, because I stored it when I go to graph, I'm now going to have those said values. Thank you. Okay. What do they need? Oh. All right. All right, so here we go. Now that we have this, we're going to compare the two. So we're going to actually find our what our y was given, so our actual, and then we're going to find our predicted and find their residual. So we should have a table that looks like this. Okay, so this is our given information, and this is from our regression. Mm-hmm. Then hit graph, and it should take you. Okay, so now we're going to look at our table and get the regression values for 1, 3, 5, 7, and 9. So I'm going to grab my calculator. To get to my table, we're pressing second graph. And I want the values for 1, 3, 5, 7, and 9. So at 1, I have 7. At 3, we have 11.1. 11 and 1/10. And then we have 15 and 2/10. Then we have 19 and 3/10. And then we have 23 and 4/10. Yes. And then to find our residual, remember your residual is your actual minus your predicted. So your given minus your regression. So y minus y hat. Did I write mine down wrong? Oh, I just can't read my handwriting, guys. Why are you going to y? It's at 9. That's why I'm like, wait, you're confusing us. We're looking at x9. Where x is 9. I was like, wait, did I do something wrong? Oh, I was like, oh, yeah, we're looking at x, not the y. So now we're doing a subtracting. So our subtracting here is, we get 0. So the residual at 1, at x equals 1 is 0. And then we have negative 1.1. Then we have 2 and 8/10. Negative 2 and 3/10. And we have 0.6. And then you're going to take those values and square them. Bless you. So for the sake of time, we have 0, 1 and 21 hundredths, 7 and 84 hundredths, 5 and 29 hundredths, and 14 and 7 hundredths. No, I already did it. I wrote the wrong number though. This is not, my total is 14. My total, I was getting there, guys. So when you find the sums of these, the sum here, 5.29. Yeah. So your sums for your residuals, you get roughly 0. And here you get 14.7. So what this tells us is that the calculator did all the squares of the residuals, and this was the smallest area sum it can come up with. And therefore, this is why this is our line of best fit. Okay. How do you feel about finding the residual and your R squared? Good? Doable? All right. Cool. That one is done.